Hello everyone. This video is in continuation with our previous video, Matter in Our Surroundings, States of Matter. If you haven't seen that video, then please do check it out. If you like it, then please give a thumbs up and subscribe to our channel. Earlier we discussed activities where we observed that solids and liquids can diffuse into liquids. Remember the activity in which we added crystals of potassium permanganate to water to obtain a colored solution. Similarly, we went through an activity in which we added drops of ink to water. Thus, with these two activities, we can say that both solids and liquids can diffuse into liquids. Gases from the atmosphere diffuse and dissolve in water. How can we say that? Have we ever thought how underwater plants and animals breathe? Gases such as oxygen and carbon dioxide are essential for survival of aquatic animals and plants. All living creatures need to breathe for survival. The aquatic animals can breathe underwater due to oxygen in water. Therefore, it is due to the property that gases from atmosphere diffuse and dissolve in water, as a result of which aquatic plants and animals are able to survive. Therefore, we can conclude that solids, liquids, and gases can diffuse into liquids. The rate of diffusion is higher than that of solids. Now, we may wonder, why is it so? This is due to the fact that in liquid state, particles are free to move and have greater spaces than solids. Given below are two diagrams. One is the case of particles in solids and another is particles in liquids. We can see that in solids, the particles are so tightly packed that the movement is almost impossible, as opposed to in case of liquids, where particles are not so tightly packed, as a result of which they are free to move. Very tightly packed, not free to move, as a result of which solids are rigid. Greater space exists between particles and hence they are free to move, as a result of which they are fluids. Moving further, we shall now be discussing the third important state of matter, which is the gaseous state. Let us start off by considering an activity. Let us consider 300 ml syringes and close their nozzle by a rubber cork. Remove pistons and fill water in one of the syringe and chalk powder in another, and leave one syringe untouched, that is, leave it empty. Insert the pistons back to syringes. Here we have drawn a syringe. This is the piston. This is the rubber cork. Now, try to compress the content by pushing the piston in each syringe. Now, we shall try to push back the piston in each of the syringe. What shall we observe? In which case was piston easily pushed in? And what can we infer? Well, obviously in the case where the syringe was left untouched, that is, nothing was filled in the syringe, it is easily compressible or is easily pushed, as opposed to the cases in which the syringes are filled with water and chalk powder respectively. Therefore, from the previously discussed activity, we can conclude that gases are highly compressible as compared to solids and liquids. LPG, which is also known as liquefied petroleum gas, is used in our homes for cooking purposes. Oxygen cylinders, which are supplied to the hospitals, and CNGs, which are compressed natural gases, are used as fuels these days. Due to high compressibility, large volumes of gas can be compressed into a small cylinder and transported easily. We all receive gas cylinders at our homes, and we all have seen oxygen cylinders in hospitals, which can easily be transported from one place to another. Let us consider an example here. We come to know of what is being cooked without even entering the kitchen by the smell that reaches our nostrils. Similar in case of hot food, the smell of which reaches our nostrils as soon as it is being served or is cooked. How does that happen? The particles of the aroma of food mix with the particles of air spread from the kitchen, reach us and even farther. Similar happens in the case when hot food reaches us in seconds. Also, we can consider an example of a room freshener where as soon as we spray the room freshener, the particles of air mix with the particles of the room freshener and spread throughout the room. Due to high speed of particles and large spaces between them, gases show the property of diffusing very fast. Like we discussed, the case in which the food smell reaches us way before it is being served, or the case in which a room freshener is sprayed in a room. All these examples show the property of diffusion of gases. In gaseous state, the particles move about randomly at high speeds. Due to this random movement, the particles hit each other in walls of the container. We all know in cases of gases, the particles have large spaces between them, as a result of which they freely move around. Due to this random movement, particles hit each other in walls of the container. Therefore, a pressure is exerted by the gas on the walls of the container. For better understanding, here we have a chart in which all the three states of matter are differentiated based on their properties. The first property is the volume. Solids possess a definite volume. Liquids also possess a definite volume, but gases do not possess a definite volume. This definite volume is due to closely packed structure of solids. Similarly, liquids also possess definite volume. They are not as closely packed as solids, but still they are not as loosely packed as gases, therefore possess definite volumes. Diffusion. Like we discussed the example in which crystals of potassium permanganate were diffused into liquids, we can state that solids can diffuse into liquids. Diffusion in case of liquids is higher than that of solids. Like we discussed, the example of ink drops in water, and in case of gases which are highly diffusible. Moving on to the compressibility, where solids are negligibly compressible. Same goes with liquids as opposed to gases which are highly compressible. We discussed this with the example of the syringes. Moving forward, we have rigidity or fluidity. Solids are very rigid and cannot flow. Like I said, due to the tightly packed structure, solids are very rigid and cannot flow. Liquids are relatively less rigid, as a result of which they can flow. Gases possess no rigidity and can flow most easily. Moving on to density, which is mass per unit volume, solids possess high density, liquids possess moderate, and gases possess low density. Shape. Solids have definite shape. Liquids take the shape of the container in which they are poured, and gases have no shape as well. Interparticle space, which is the least in case of solids because they are tightly packed. In case of liquids, it is lesser but still more than solids. In case of gases, the interparticle space is the maximum. Moving on to the forces of attraction. In case of solids, the forces of attraction are very strong, as a result of which they are so close, the particles. Forces of attraction in liquids are less than that in case of solids, and in case of gases, they are the minimum. Arrangement of molecules. Solids are packed in definite pattern, so they possess geometry and are of fixed shape. Liquids are weakly packed in comparison to solids, therefore they possess the shape of the container in which they are placed. Gases are packed very poorly, so they fill the container and obviously have no shape. With this, we come to an end of our today's video. We discussed in details properties of gaseous state of matter and differentiated between three states based on their properties. If you liked this video, then please give a thumbs up and subscribe to our channel. Thank you.